Before looking at inequalities, let's draw a number line from -6 up through +6. What number would you say this point represents? If you're not sure, click down here to review. Right, it's about 3.5, or 3.5. Now let's look at an inequality, like this one, which you can read aloud as x is greater than 2. This means that x is some number bigger than or greater than 2. So which numbers are solutions to this inequality? Of the 5 numbers down here, which of these are possible values for x? Which of these are greater than 2? Right, -3, 0, and 2 are no good, while 3 and 6 are both greater than 2. So let's plot all the solutions to this inequality on the number line down here. 3 is a solution, so we can draw a dot at 3. And 6 is also a solution, so let's draw another dot at 6. And all the numbers between 3 and 6 are also greater than 2, so let's add some more dots. And if a number is greater than 6, it's definitely greater than 2, so we can keep adding dots in this direction. Now these numbers over here, between 2 and 3, are also greater than 2. But the number 2 itself is not greater than 2. It equals 2. So to make it clear that 2 is not part of our graph, we can put a hollow or open dot at 2. So which numbers are greater than 2? Not the number 2 itself, but every number to the right of 2. Now instead of drawing lots of dots, you can draw this as an arrow pointing to the right. So this is the graph for the inequality x is greater than 2. Next, try identifying which is the correct graph for this inequality, which says that x is less than -3. If you're not sure, feel free to ask for a hint. Exactly right. Here's the graph for x less than -3. -3 itself is not a solution, so we have an open dot, and the arrow extends left on the number line. These are all the numbers less than -3. Next, let's look at another inequality. This symbol means greater than or equal to. So which of these numbers are solutions to this inequality? Which of these numbers are greater than or equal to 1? Right, -3 and 0 are no good. 2 and 5 are both greater than 1, and 1 equals 1, so all of these are solutions. So let's plot this inequality on the number line. Again, 2 and 5 are solutions, and so are all the numbers between them and all the numbers greater than 5. The numbers between 1 and 2 are also solutions. And what about 1? Well, instead of having a hollow or open dot, we can make it a filled or closed dot. This means that 1 is a solution to our inequality. So here's the graph for x greater than or equal to 1. It's a closed dot at 1 and a line that goes off to the right. Next, try identifying which of these is the correct graph for this inequality, which says that x is less than or equal to -2. Precisely, here's the graph for x less than or equal to -2. All the numbers less than -2 are solutions, and -2 itself is also a solution, so we have a closed dot. Now suppose you have the inequality y is less than 5. It turns out there's an equivalent way to write this by flipping it around. And now it says 5 is greater than y. If you think about it, saying 5 is bigger than y is the same thing as saying y is less than 5. So these two expressions are equivalent. They mean the same thing. So then how else can we write this inequality? X is less than or equal to -2. Is it the same as -2 is less than or equal to x? X is greater than or equal to -2? Or -2 is greater than or equal to x? Right, if you flip this inequality around, you get -2 is greater than or equal to x. So these two inequalities are equivalent. And there are actually a few different ways to read these inequalities aloud. You already saw that this one is x is greater than or equal to 1, and this one is x is less than or equal to -2. You can also read this one as x is at least 1. If you think about it, it makes sense. If x is at least 1, that means it could be 1 or any number bigger than 1. In other words, x is greater than or equal to 1. And another way to say this is that x is at most -2. So x could be -2, but that's the most it could be. So it's any number less than or equal to -2. And finally, this can also be read x is no less than 1. So if x is not less than 1, it could be greater than 1 or equal to 1. Similarly, you can read this as saying x is no more than -2. So there are a few different ways to say the same thing. Try an example. Suppose a sign in an auditorium says that it can fit no more than 500 people. If we say there are p people in the room, then which of these is the correct inequality for p? Okay, now it's time for you to plot your own solutions for inequalities. To make different graphs, you can drag around the dot and you can drag on the arrow to make it point to the left or to the right. And clicking this button here lets you switch between having an open and closed dot. So here's your first challenge. Plot the inequality x is less than 0. Once you've got it, press the Submit button over here, and feel free to ask for a hint if you get stuck. Exactly right. You have an open dot at 0 and the arrow points left. So this is the graph for x less than 0. Next, try graphing this inequality. 3 is less than or equal to x. Right, so saying that 3 is less than or equal to x is the same thing as saying that x is greater than or equal to 3, and that's the graph you drew. Next, try graphing the inequality for this statement. X is no less than -2. You're on the right track. Saying x is no less than -2 means x can definitely be greater than -2, which is what you've graphed here. But x can also equal -2. Think about it. If x equals -2, then it's not less than -2. So saying x is no less than -2 is the same as saying x is greater than or equal to -2. So give this question another shot. Excellent! Saying x is no less than -2 is the same as saying x is greater than or equal to -2. And here's the correct graph. A closed dot at -2 and an arrow pointing to the right. And how would you plot this statement? X is at most 3. Right again. If x is at most 3, then x is less than or equal to 3. So for your final challenge, try a graph with a decimal. Plot the statement x is greater than 1.5. To get started, why don't you plot the inequality -2.5 is greater than x on this number line over here. You can drag around the dot, you can drag the arrow to make it point left or right, and you can click this button to switch between an open and closed dot. And click over here if you'd like to review. Great, so let's briefly move from inequalities to equalities, or equations rather, like this one here, 4x minus 9 equals 11. Try solving this equation for x, or click down here to review solving equations like this. Nicely done. So you can think of an equation as a balanced scale. The equal sign means you have the same amount on one side as the other. If one side is bigger than the other, then it's no longer an equation. It's an inequality, and you use the greater than or less than symbols. So let's balance things out and return to an equation. If you ever change one side of an equation, you can keep it balanced by making the same change to the other side. And you can do this over and over again. So to solve this equation, you can do the same thing to both sides. First, you can add 9 to both sides. The 9's on the left cancel out, leaving us with 4x equals 11 plus 9, or 20. Then we can divide both sides by 4. So these 4's cancel out, meaning x equals 20 divided by 4, or 5. So to solve equations, you do things to both sides until you get an equation like this, where x equals a number. Now what about inequalities, like 4x minus 9 is greater than 11? How can we solve this? How can we find all the values of x that satisfy this inequality, where this expression is greater than 11? Well, this inequality is saying that the left side is bigger than the right side. Now if we do the same thing to both sides, the left side will still be bigger than the right side. So our strategy still works. As long as we do the same thing to both sides, the inequality will still be true. So what's the first thing you would do to simplify this inequality? Would you add 9 to both sides, subtract 9, add 4, or subtract 4? Right, solving this inequality is just like solving an equation, so our first step is to add 9 to both sides. Again, the 9's cancel, and so we have 4x is greater than 11 plus 9, or 20, and we can again divide both sides by 4. So now x is greater than 20 divided by 4, so x is greater than 5. And that's the solution for this inequality. If you plug in any value greater than 5 for x, like 6, then the inequality will be true. 4 times 6 is 24, and then minus 9 is 15. So 6 is a solution. 15 is greater than 11. But numbers that are not greater than 5, like 4, are not solutions. 4 times 4 is 16, minus 9 is 7, which is not greater than 11. So the solutions for this inequality are all values of x greater than 5, and these two inequalities are equivalent. So solving an inequality is just like solving an equation. If 4x minus 9 equals 11, then x equals 5. If 4x minus 9 is greater than 11, then x is greater than 5. And if 4x minus 9 is less than 11, then x is less than 5. Why solve inequalities like this? Well, suppose you were asked to graph 4x minus 9 is greater than 11. Which of these is the correct graph for this inequality? Exactly. These two inequalities are equivalent, so they have the same graph. This one, which says x can't equal 5, but x can be any value greater than 5. Now it's time for you to solve and graph inequalities. First up is this inequality. 2x plus 3 is less than or equal to 1. So first, solve this inequality and then graph it over here. And feel free to ask for a hint if you get stuck. Exactly. The original inequality was 2x plus 3 is less than or equal to 1. And you solved it to find that x is less than or equal to negative 1, which is this graph here. So nicely done. Try another example. Plot the solution to the inequality 5 plus 2x is greater than 8. Precisely. 5 plus 2x is greater than 8 simplifies to x is greater than 1.5, which is this graph here. Okay, for your final challenge, plot the inequality for this statement. 8 is at least 3x plus 2. So first, you'll want to write this as an inequality, then solve, and then plot. Again, feel free to ask for a hint if you need one. You've done some excellent work here, and you've gotten some practice solving and plotting inequalities like this one here. Now something unusual happens when you try to solve inequalities that have negative coefficients, but we'll save that for a later lesson.